Jet streams are narrow bands of high-altitude winds, often reaching speeds of 450 kilometres an hour, which have a profound effect on the weather. And as the world gets warmer, the behaviour of jet streams is one of the most studied and hotly debated mysteries of climate change. New research suggests that deviations in the North Atlantic jet stream are linked to ice melt in Greenland's glaciers and is causing more turbulence at aircraft altitudes. Professor Paul Williams is lead author of the research, published in the journal Nature.
Jet streams are very important because they blow weather systems around the world. So, for example, they get blown across the Atlantic Ocean and hit Europe. So we're very interested in the jet stream. If it moves north or south or speeds up or slows down, that's all got consequences for the weather systems that we experience.
But let's take the ice melt in Greenland. Is that as a result of warming temperatures per se, or are those warming temperatures caused by unusual movements in the jet stream?
Well, that's a good question, and it is a two-way influence. The climate system is very complicated and there are multiple factors at play. But we're very confident that the loss of sea ice and the warming of the Arctic is a consequence of the CO2 that we've been putting into the atmosphere and the global warming that it's caused.
So where does the jet stream come into it?
Well, what we found in the study that we've published in Nature this week is that humans have changed the climate so much through our CO2 emissions that there's now 15% more wind shear in the jet stream than there was 40 years ago. This is the jet stream over the North Atlantic Ocean at typical aircraft cruising altitudes. And this is one of the biggest changes we've observed in the climate system since satellites started monitoring it in the 1970s. But it's gone unnoticed until now. And what it means for air travellers is a lot more turbulence on their transatlantic flights.
What is wind shear?
Wind shear, good question. It's the effect by which the wind speed increases with height. So the higher up you go, the windier it gets. So it's that increase in wind speed with height that continues all the way up to 10 or 12 kilometres and forms the main core of the jet stream.
And that is a consequence, this increased wind shear, of climate change.
There's a balance in the atmosphere between the temperatures and the winds. And what that means is that any change to the temperatures through, for example, global warming and climate change is inevitably going to modify the winds as well. And we know that the particular way the temperatures are changing up there at 35,000 feet is such that the temperature difference across the North Atlantic Ocean, the north-south temperature difference is getting stronger because of climate change. And that's causing the wind shears in the jet stream to strengthen as well.
Your research is on the North Atlantic jet stream, but is there reason to believe that jet streams in other parts of the world are starting to behave unusually?
Yes, there is. You're quite right. The jet stream blows all the way around the northern hemisphere, and there's another one in the southern hemisphere as well. And these temperature changes that are driving the shear increase in the jet stream are occurring all around the world. And we're currently analysing and crunching the numbers for North America and the Pacific and Eurasia as well.
So the consequences of greater turbulence on transatlantic flights presumably means that planes will have to take alternative routes in order to avoid that turbulence, and that in itself means more fuel being burned and higher CO2 emissions.
That's right, and it's slightly ironic, isn't it, that aviation is partly contributing to climate change, but might be a victim of climate change as well, because you're absolutely right. If a plane is taking off and there's 2 or 3 times as much turbulence in the atmosphere, and that's what our projections are indicating, then it's less likely to be able to take the most direct route, and it's more likely to have to divert around the patches of turbulence, which means a longer journey, more fuel burn, a greater fuel cost to the airline, delayed arrivals, all of these sort of impacts we're going to see potentially in the coming decades.
Professor Paul Williams, lead author of research published in the journal Nature, which was looking at deviations in the North Atlantic jet stream.